Hey guys, let's say you went home and you decided you're going to make a frozen pizza in the oven. You place that pizza in the oven, and after about 20 minutes, you go to grab it and you pull it out by hand. You would never do that because you know that that pizza is much hotter than your hand. And so if you grab it with a bare hand, you're going to burn yourself. When energy is transferred from one object to another object, we call that type of energy heat energy, and it's based on a temperature difference. So you've got a very hot pizza and you've got a very cool hand, and energy is just going to flow from that pizza into your hand, and you're going to burn yourself. The way that we measure heat energy in chemistry, we give it the symbol Q. We give it the symbol Q, and we say that it is measured in a unit that you're probably familiar with at least a little bit, called the joule. One way to think about a joule is do this right now. Take one hand and just hold it open, palm up, and take one finger, your index finger, from your other hand, and as lightly as you can touch with that index finger the palm of your hand. That's about a joule's worth of energy. At least that's what I've always been told. It's really uh, close enough, anyway. So, what would you instead use to retrieve that pizza? You might get out an oven mitt. Now, you've seen oven mitts made out of like silicone rubber or some sort of fabric, probably cotton, but you never see an oven mitt made out of aluminum foil or some other metal like that. Why not? And the reason is that you can just intuitively know that if you tried to pull a pizza out of the oven using aluminum foil, that you would burn your hand again. Why? Because that aluminum foil heats up very rapidly. On the other hand, substances like silicone rubber um, or like cloth of some sort, fabric of some sort, they don't heat up so quickly. And what we're talking about there is something called the specific heat of a substance that we give capital C to indicate it. And it is specific to every substance. In fact, every phase of every substance has a specific heat. Some things are very easy to heat up, and some things are not so easy to heat up. You looked at the definition of specific heat, it is defined this way: it's the amount of energy needed to raise the temperature, so increase the temperature by 1 degree Celsius for 1 gram of that substance, whatever that substance is. So let me say that a little bit more clearly. It's the amount of energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay. So things like rubber or fabric have high specific heats. It takes a lot of energy to raise their temperatures. Things like aluminum have low specific heats. It doesn't take nearly as much energy to raise the temperature, and that's why they heat up so rapidly. Oftentimes, we'll be asked to calculate maybe the specific heat of a substance, or to calculate how much heat is needed to raise the temperature of a substance, et cetera, et cetera. And we do so with an equation given here: Q equals mc delta T. Some people say Q equals mcat. Q, again, is heat energy measured in joules, but on the right side of the equation, we have mass, which we're used to, and measured in grams. We have specific heat capacity measured in joules per gram degrees Celsius. Let's talk about that unit a little bit. Joules is energy, grams is mass, degrees Celsius is temperature. So joules per gram degrees Celsius, amount of each energy needed to raise the temperature of 1 gram of a substance. Okay, good. Delta T, that's change in temperature. Anytime you see that triangle in science, it means change in or difference in. So change in temperature is measured in a specific way for us. It's always final temperature minus initial temperature, and that is measured in degrees Celsius. In our next video, we'll show how to actually put this equation into use by doing a problem, um, and we'll see you next time. Great.